Hey, it's Mr. K doing a problem for AP Physics C Mechanics. It's a multiple choice problem, and I'm going to do some derivation for it. This is one where you have a football player, they throw a ball, and the ball goes a distance of 80 meters. And it's the maximum that they can throw it, so we know that their shot, their throw, starts off with an angle is about 45 degrees. 40, let me enunciate a little better, 45 degrees. And so this velocity here, it should be broken up into components. Now what we know is that the velocity in the vertical, this Vy, should be equal to the velocity in the horizontal, which is a Vx. And this is a purely kinematics problem. I'm going to go ahead and solve it one way. There could be multiple ways to solve it. This is just the one that comes naturally to my mind. And then as you get better at doing kinematics, maybe you would stumble on a faster way to do it. But this is just a way that comes to my mind first. And then we'll do something called the range equation. That could help you solve it even faster, but it's going to require you to memorize it. I'm not a big fan of that, as you know, but you can still use it. So, 80 meters to go. What you know is that in kinematics, the delta x is equal to the velocity in the x times the time. And something special here, once again, is that the x velocity should be equal to the y velocity at the start. All right. In the y direction, we know that the delta y is equal to the velocity in the y direction times time plus half a t squared. And in this particular problem, we go from the ground to the ground. And if we go from the ground to the ground, the change in y is 0. And if the change in y is 0, then these two terms should be equal to each other. So we just make them equal by saying that Vy delta t is equal to the 1/2 g delta t squared. Now, if you're wondering why that y1's negative here, if we can do that, when you plug in g should be negative, so it will make this math work out. Looking at the t's cancel out. So Vy is equal to 1/2 g delta t. All right. Moving on, if we want to find the maximum height, then we probably want to use an equation that, well, that doesn't have an unknown in it that we don't possibly know. We don't know Vx, we don't know Vy. We just have a number that is the 80 here. And so really, I should want to use the equation Vf squared is equal to V naught squared. This is Torricelli's equation, plus 2a delta y. So my goal here is to get, well, the final velocity at this point should be 0. So my goal here is to get this initial velocity. I know a, and I'm looking for delta y. So if I can find initial velocity in the y direction, then that'll be awesome. So looking at this, I'm going to go ahead and combine these two equations. And in order to do that, let's go ahead and solve this one for time. So delta x over Vx should be equal to delta t. I'm going to plug that in over here. And that says that 1/2 g delta t is going to be delta x divided by Vx. And now I have this equation that says that my velocity in the y direction should be equal to the 1/2 g x over velocity in the x direction. And we'll use the convenient fact that the velocity should be equal. So my velocity, move it over, in the y direction squared, is equal to g delta x divided by 2. Okay? And that's useful because I'm going to plug it in right here. So my velocity squared, that's what velocity squared. So I'm just going to say g delta x divided by 2 minus 2g delta y. All right, that negative again is from that gravity that we plug in, that acceleration due to gravity. Well, if that's 0, then that says that these two things should be equal to each other. Moving the 2 and the g over, the g's cancel out. So really, it comes down to delta x divided by 4. And delta x is going to be 80, and 80 divided by 4 is 20. So from that derivation, what we see is that the change in position divided by, well, 4 pretty much, that should equal your max height. Okay, that could be something to either memorize or just could help you solve it faster. I'm not sure. That's the end of the problem. I'm going to show you one more thing, and that's going to be called the range equation. Now, not a big fan of using the range equation because I feel like this is one of those memorization things, but it is an equation, it is a valid equation, and it is a useful equation. So the range equation says that the change of position is equal to the velocity times the cosine of theta, which would be the horizontal component of velocity, multiplied by the time. Okay? And so we're just going to find an overall equation that says, hey, based on an initial velocity and the angle, it should help us define the range. Well, for flat ground. So it has to be flat ground. That's what I'm going to derive from here. So in flat ground, I know my delta y is 0. So I'm going to say delta y is equal to 0. And that's going to be equal to my velocity times the sine of theta. And the reason why I'm using sine and cosine is because the angle might not be 45 degrees. I know this one we just did 45 degrees, but deal with it. This will be a general one. So v sine theta times time plus 1/2 a t squared. So again, just like we did before, we're going to move this over and we're going to say, hey, v sine theta times time is equal to our 1/2 g t squared. And again, when we plug in g over here to become negative, when you move it over, it becomes positive. Works out. One of the times cancels out. Can't believe how often we forget that you can just divide both sides by t. Helped out a teacher today, actually, yesterday, maybe, forget, but recently, that was trying to use the quadratic equation, the quadratic formula to solve this. And I was just like, dude, just divide both sides by t. So there's that. Let's go ahead and just move that 2 over and move that g over. So we're going to have 2v sine theta divided by g is equal to time. We're just going to plug that in right over here. And so our change in position is equal to, our range really is equal to v cosine theta times 2 times v times the sine of theta divided by g. And cleaning that up, our delta x, our range is going to be equal to v squared 2 sine theta, because I like to put that first, times the cosine theta divided by g. Now, that's not going to be it. There is one more step that we can do, and the step that we're going to do here is going to say, hey, 2 sine theta cosine theta, that's actually a trigonometric identity, and the trig identity is that 2 sine theta times cosine theta is going to be equal to 2, or equal to sine of 2 theta. Got to slow down my talking. So delta x is equal to v squared, 2 sine theta cosine theta, turns into the sine of 2 theta, and that's going to be divided by g. So this is what's called the range equation for flat ground. Based upon your initial velocity and the angle theta, you're going to get some position change x. And just to kind of run this through, if we were trying to look at this problem, what we know is that our angle is 45 degrees. If we plug in 45 degrees here, 45 times 2 is 90. The sine of 90 is 1, right? The sine of 90 is 1. So we get v squared divided by g is equal to the delta x. All right? Now, if that's the case, in this problem, we know that delta x is 80. So I've got 80 multiplied by g, that's 10, so that's going to be 800 square rooted. The velocity in this problem is going to be the square root of 800. All right? If we wanted to find the maximum height, then again we would say, you know, we don't have time, all we have is velocity here now and acceleration. We would just plug it into this equation. The vf squared equals v naught squared plus 2a delta y. Okay? This is, whoop, what? There goes my light. If we know that the final velocity is 0 for maximum height, so our initial velocity, v naught squared, which is actually going to be this thing, but the horizontal or the vertical component of it. So we're going to say that the v naught is equal to v square root of 800 multiplied by the sine of 45, or rather the square root of 800 times the square root of 2 divided by 2, or rather the square root of 1600 divided by 2, or rather 40, right? Yeah, going stupid. Hold on. Square root of 1640. Yep. 40 divided by 2 is equal to 20. Okay, so V naught is 20. So I'm going to say V naught is 20. This is 0. That's 20. 20 is going to be squared plus 2 negative 10 for G delta Y. All right. So I've got 20 squared. It's going to go back up to 400. 400 divided by 20 again, because, 2 times 10, that gives you 20. So just doing the math here, again, 400, moved over, is equal to 2 times 10, that's 20, so divided by 20, and that's going to be equal to 20 again. That is your change in y. So your range equation can really quicken this up for you if you memorize it. This is the range equation. That math could be condensed and, I talked through it so you can do it a lot faster. If you wanted to work from basics, you could. It's right here. That's totally fair. But this was a purely kinematics problem. Either way should work. There's probably another way to do it. But I'm going to stop with these two. So that'll be it.